So now we have the fundamental theorem of calculus, which tells us how to compute these definite integrals. So what we really need now is a good way to compute antiderivatives, right? Because that's what the fundamental theorem relies on. So we know how to compute antiderivatives of things that we know are derivatives of other things. But what if it's hard to see that at the beginning? Like, what if it's the result of a chain rule, for example, or a product rule? Right? Those derivatives, sometimes you can see them. Sometimes it's a little less obvious what the antiderivative should be. So we want to think about, well, how could we possibly go about that? How could we go about fixing that? Or computing these antiderivatives? Well, think about what rules we had for derivatives. We sort of had the basic things, like, the derivatives of our basic functions, the power rule and stuff like that. And then based off those, once we had that foundation, we used the product rule and the chain rule to compute derivatives. So it makes some kind of sense to think, well, when I want to do antiderivatives, I have my basic set of functions that I have the antiderivatives for. These are the things that are known to be derivatives of things, right? And then once we have that, we should look to say, well, how do I undo things like the product rule and the chain rule? And that's going to be the topic of these next two lectures here, right? So what we're actually going to start with is the chain rule. So let's look at the chain rule, right? Chain rule says d dx of f of g of x is equal to f prime of g of x, g prime of x. All right? So we want to undo this derivative is what we're basically asking here. Okay? So let's look at this. What we want to do is integrate both sides of this equation here with respect to x. So integrate this and integrate this side. Okay. Now let's look at this side here. Right? When we have that, the integral and the derivative, we're integrating the derivative, so those two are just going to cancel each other out. So this right-hand side is just f of g of x plus c. Right? And this right here is actually undoing the chain rule. This is what we often call the substitution rule. Okay? So a better way we write this usually is to say, okay, or let's just write this as a rule here. So the substitution rule. Oops. Right, so I'll leave off some of the technicalities here. I'll let you read that in the textbook. But basically what we're going to do here is say, let capital F of x be an antiderivative. Actually, let's leave off the of x here. Let capital F be an antiderivative of little f. Okay. Then, that formula above that we just came up with reads like this. The integral of f of g of x, g prime of x dx, is equal to capital F of g of x plus c. Right? Now, this is often referred to as U substitution. So how does that look? So if we write u equals g of x, then integral of f of g of x, g prime of x dx, this is f of u times du, right? So du would be g prime of x dx. So this stuff right here is du. So here we have u, here we have du, right? And then there we go. So now this turns into just integrating this outside function f, and then we plug the inside u back in. So we end up with this, right? So we're basically kind of using the chain rule backwards to kind of pull out the inside of the function, integrate f, and then put that back inside, right? So that's pretty much it for the theory behind the substitution rule. Let me also say this does work as well with definite integrals. Okay. So for definite integrals, right? So if we have integral from a to b of f of g of x, g prime of x dx, right? We're still going to do u equals g of x. And then what we need to do is we need to swap everything we can to be in terms of u. So this part doesn't change. We still have f of u du. But what changes is the bounds. So here, when we're swapping g of x for u, we have to say, well, what is the output of g of x going to be? So we take this a, we plug it into g. So this bottom bound is g of a, and this top bound is g of b. So when we do it for definite integrals, not only are we switching the variable here from x to u, we're also changing the bounds. These bounds are in terms of x. We take a, plug it into here, and we get that new lower bound. We take b, plug it in here, and get the new upper bound. In other words, when x is equal to a, u is equal to g of a. When x is equal to b, u is equal to g of b. All right? So we'll see how this works in a couple examples after this. But this is one of the big two rules for integration right here. We have the substitution rule, which is undoing the chain rule. And then we'll talk later on about the next rule, which is undoing the product rule.